Okay, so welcome everyone to another DASI Solutions webinar. I'm Jared Spaniel, an application engineer out of our Fresno, California office. Today we're going to be talking about some different modeling strategies, mainly focusing around the top-down design techniques and some other things with internal and external parts, and hopefully going to bring you guys some cool info on all this stuff. So coming up, what are we going to look at today? We're going to look at a few different methods, do some compare and contrast so you guys kind of get the whole picture of what we're actually talking about here. We're going to look at how to choose, so kind of a best practices on how to actually choose the different method that would be best suited for your application. I've got some best practices going on, a few tips and tricks I kind of want to show along the way, and just general best practices within SOLIDWORKS when utilizing these strategies. I've also got kind of what I'm calling a things to know slide toward the end, which is a variety of different things related to system options, various ways you can do things, and other stuff related to these different strategies that I think you should probably know about. And then going to close it out with a couple calls to action for you guys to actually take some next steps, where to learn some more about this info and those types of things. And so let's take a look at what we're actually talking about here, right? So the first thing we need to address is what is top-down modeling, right? So top-down modeling is very simply, it's a modeling strategy used to drive multiple part designs, which include features and sketches using a parent part, right? And what I mean by that is, if you guys are familiar with SOLIDWORKS, you probably already know about a parent-child relationship in SOLIDWORKS. So whenever you create a child part, it is now related back to a parent part, and that can be with a feature as well. So if you look at your feature manager tree in SOLIDWORKS, you'll now see the new dynamic reference visualization, which basically shows you which parts are related and have their parent-child relationships. Same thing with components. So for instance, in my example here that I've shown on this slide, I've created this child part, which is the red part, which is just a simple cover for this ratchet head. The parent part being the green part. Whenever the parent part changes, for instance, if I change the radius of this part, then the cover will follow. Everything updates accordingly. So very easy to make changes and have other parts follow, right? And we're actually going to look at a real-time example of this part in SOLIDWORKS. Another thing we need to actually do is compare a couple different methods or strategies. We're primarily going to be talking about top-down modeling here, but you can't really have one without the other. So you kind of need to know top-down versus bottom-up, right? And this is a pretty common question, and the difference in the two is pretty straightforward, but let's take a look at some of the differences between top-down and bottom-up. So top-down is basically you have your parts being created what we call in context. And what I mean by that is you're actually establishing external references with your components. So you're basing some kind of sketch or feature on another sketch or feature or part. So now they are related, right? And that is known as an external reference. You also have automatic update of parts. So when one change is made to a part or an assembly, then the other parts that are related to it or have those external references tied together then follow along, right? And that's kind of the big benefit of top-down modeling. One other thing to note here that I like to bring up is watch out for your design intent with top-down modeling, because you are going to have things down the road that are going to be changing while other components change, right? So you want to make sure that your design intent stays in line with what you actually intended it to be, right? Top-down modeling is really good, mainly for one-off designs, and especially if you're going to have frequent changes or things that you want to update, right? And we'll talk a little bit about why that is and what the difference is between bottom-up related to that as well. So bottom-up modeling, really good for independent parts. And what I mean by independent parts is you basically would have these parts modeled separately in their own files, and then you would bring them into an assembly, mate them together like building blocks with your typical mate commands, and then you would have that bottom up where the parts are not interdependent of one another. You can make a change to a part in your assembly and nothing else in that assembly will really change, right? It is a little bit more manual in that manner, meaning if you change the design, you need to update the parts accordingly, right? So if you move a hole and they're not related, then you need to go in there and make sure that the other holes that are mounting to that or mated to that hole continue to line up with that hole, right? Otherwise, then you have holes that are offset and things don't line up and it causes problems, right? So more manual changes. Bottom up is really good for parts or assemblies that are being reused. So if you are reusing anything in multiple assemblies or you're building around other assemblies and then reusing components to build off of, good to do that in a bottom-up strategy and not have those interdependent relationships because they can cause issues down the road. Quick tip here is there's nothing saying that you have to constrain yourself to one of these approaches or the other. Probably in most scenarios, a hybrid approach is going to be your good approach to consider. Different parts, different sub-assemblies and assemblies require different techniques, right? So for instance, you could start in a bottom-up assembly, build your assembly up with your components, and then transition into a top-down and, you know, make certain components within that assembly be modeled in context and establish those internal relationships. So it doesn't have to be one or the other. That's not what I'm talking about. So why would you want to use a top-down strategy? Well, first off, it's easy to maintain relationships between parts. So for instance, you can easily add a clearance and have that be maintained. You can reference other components so you know where things are. You can maintain your position in the assembly very quickly and easily. You can also make very quick modifications to parts. And we talked about this a little bit already, but basically if you have one change to a parent part, it's going to propagate to your child part, right? So less manual updates, things kind of automatically update for you, right? And there is other methods that you can utilize to do this within SOLIDWORKS, such as, you know, design tables, equation-driven sketches, configurations, those types of things, right? But for now, we're just talking about references in context modeling and top-down strategies. One thing to kind of note here before we jump into a couple of the examples that I have is we need to talk about some feature manager symbols. And you probably have already seen these, and you might have been asking yourself, what does that mean? Or it just appeared and now I don't know what is happening. The first one is the arrow. That just basically means that you have established an external reference, right? And once you do that, your feature or your sketch will be followed with that little arrow. If you have the little arrow with the question mark after it, that means you've somehow lost that external reference and it's now out of context, right? So SOLIDWORKS doesn't know where your reference is actually belonging to. And you need to either go in there and tell it where it's belonging to or reestablish that in a few different methods, right? The next one is the one with the asterisk. So that basically means that you've now locked that reference so it cannot be changed. So if parts are updated, that reference will stay the way it has been. We'll talk a little bit about these in the examples, and I'll show a few ways to get to these. If you have an X after your arrow, that means that you now have a broken external reference. If you see the little double arrows, so if it's an arrow and then brackets, and then followed by brackets with another arrow in it, that basically just means that you have a feature and a sketch that both have external references. So you can see in my example picture there, I have the sketch has an external reference, and then the feature has an external reference, and then it denotes right after that in brackets, there's another arrow denoting that you have multiple external references. Another thing to talk about is internal, also known as virtual parts. And the way that you know if you have that or not is if you have a bracket around your part name. So you can see in the part for machine vice there, I have brackets around my part name, and that indicates that it is an internal or virtual part. The color indicates that it is currently being edited, so SOLIDWORKS easily lets you know what you're editing when that part basically highlights in whatever color. Blue is the default. We can change that. We'll talk about that a little bit in the example as well. So a couple different examples. I have three specific examples I kind of want to go through here that show a variety of different methods, different options, and different things that we can do with creating external references. I also want to show you guys a couple commands that are extremely useful when working in top-down modeling, and things that will definitely be super huge time savers whenever you are doing the top-down modeling methodology. So the first one I have here is just basically adding a feature with an external reference, and we're going to utilize this oil pan tube model to do that, right? So what I have here is my assembly, right? And I have an oil pan with a tube. And what I actually want to do is create the feature that connects my oil pan to my oil pan tube. So I need some kind of mounting plate and some mounting holes and a pass-through hole for this tube, right? So you could do this in a bottom-up strategy, right? But what is the difficulty with bottom-up strategy in this case is you would have to know where the holes are located, what the size of the holes is. So you'd have to do some measurement of your tube and your bracketry beforehand, right? You have to figure all that information out. You'd have to figure out the position on the plate, and you'd have to come in here and model that, and then you'd have to be flipping back and forth between the part and the assembly to check and make sure that things are lining up, right? So it's a bunch more steps. It's a little bit more complex. It takes more time. It's tedious, right? So perfect example is we don't really want to do that in this case. This is a good example to use top-down modeling, right? So the first thing that we're kind of going to do here is we're just going to edit the part. So we're going to edit this part, right? So we're going to say edit part. You can see now that my part goes blue in color, and it goes blue in color on my feature tree, letting me know that I'm actually editing. I'm going to show a couple system options along the way just so you guys know where things are. If you want to change this color, say you don't like the blue color, you can always change that color very easily. If you go into the system options, go up here to colors, and then on this list called color scheme settings, if we browse to assembly, so if I scroll down here and say assembly edit part, you get this color over here, which is blue. If we say edit, we can now change the color of the part being edited, right? So any of these colors, it will change the color on the part itself and the color on the tree. So for instance, if I want it to be orange, I can say OK. We can say OK here. My part now switches to an orange color, right? I will switch that back to the default here. So if I jump back in here to colors and then go to assembly, edit part, say edit. This is the default color, say OK. And now back to blue. So you can change that if you so wish. Very easy to do. So I'm going to point out a few of those things as we go. Right, so we're currently editing this part. I'm going to do a new sketch. So I'm going to grab this sketch and I'm going to say I want to sketch right here, right? A few tools or commands I want to point out at this point, right? I could do just some sketching with your typical splines, lines, radius, arcs, those types of things to outline this geometry. But there is a much easier way to do this, and the two tools that are really great for top-down modeling are these two guys right here. Number one being convert entities, and number two being offset entities. And what these basically allow you to do is trace geometry that's already existing. So for instance, if I do convert entities, it's going to ask me what entities I want to convert. Well, I want to convert the outer perimeter of this face right here, this bracket. So I'm going to do that face, right? I'm going to hit the green check, and now it's automatically going to convert that geometry onto this face that I'm now sketching on, right? So we've got one piece done, right? So the second piece we need to do is grab my hole. So I have two mounting holes and then a pass-through hole for my oil, right? So I'm going to say convert entities again. And this time what I'm actually going to do is do the inner loops, right? So I'm going to say I want to grab this face again. And SOLIDWORKS added this really cool feature a few years back called select all inner loops. So you could pick these one by one, but now I have this option to say select all inner loops, and now you can see that SOLIDWORKS highlights the three loops that I have. I will hit the green check here again, and now you can see that I have a complete sketch. So what I can do with that guy is now I can create that feature by doing a simple extrude, right? And I can use the existing geometry of my bracket by just saying that I want to go up to the surface of this piece right here, right? So it's automatically going to reference that geometry. So now I have that feature created referencing this geometry, right? So if I hide that guy, what we can see is if we look over in our feature tree right here, we now have exactly what we talked about in the symbols, right? We have a feature that has an external reference, and I have the brackets with another external reference since I created a sketch that has an external reference as well. So I have multiple external references for this feature here. So with that, we can now, obviously, we need to make some cut-through holes for our mounting and our pass-through here. What I want to show is reusing this same sketch. So let's do a cut. I'm going to do a cut on this surface, and let's do that convert entities again. So if we do these three entities, right, same thing, the green check. So we've got our new sketch there, and then we're going to jump right into a cut. So we'll make our cut, and we'll just say we want to do through all, right? So now we've created our cut holes here, right? So we've basically utilized that sketch that was already existing, did another convert entities, and we've created a cut. So that completes that geometry. So if I hide this sketch, bring back my pipe, you can now see that that has a completed geometry. I can check out of my component. So the beauty of this, right, is now we have a reference between this part and this part of our oil pan. So if I wanted to come in here and change anything on this part, this should update, right? So for instance, I have some 10 millimeter holes here. Say I want to bump this up to an M12, rebuild. If I hit rebuild and the green check, right, what happens is now both of those holes update accordingly, right? So if we look at this normal too, we can see that the hole size has changed on both holes with just making the change to the one component, right? So that's kind of the power of the top-down modeling that I'm getting at. That was example one, kind of showing a few things there, a few options. The second example I wanted to show was starting more in a bottom-up scenario and then adding top-down components. So this is kind of your hybrid modeling option, right? And I'm going to be utilizing this ratchet cover for this example. So what I want to do is create a little cover that covers up some of this internal mechanisms here, right? So you can see here I have an assembly. I have no external references going on between these components. They're basically created in a bottom-up strategy and then brought in, mated in place, and we don't have any external references going on, no top-down. So what we're going to do at this point is a little bit different of a workflow. We're going to actually insert a new component. So we're going to say insert, new part. And now what you can see here is I have a new part in my tree, and it's asking me where I want to place this part. And that is denoted by the little green arrow next to my cursor here. I want to place it on this face. So I will select this face. It automatically jumps me into edit mode, and I'm now editing this new part that I have. We talked about convert entities a little bit. This time let's use some offset entities because of course in this case we don't want to have, or we want to have a little bit of clearance between our cover, and then we also want to have some clearance holes for the mechanisms that are already in place here for our ratchet, right? So we need to actually add some clearance. So offset entities, select this edge, this edge, this edge, right? And now you can see that it's going the wrong direction, very easy to fix. There's a little reverse checkbox over here, just hit reverse. And if you can zoom in here a little bit, you can see now that I have that clearance right there, right? So that creates my clearance, and it's a fully defined sketch. We can do the same thing for these other two. So we just need to make sure that we pick the right entities here. We'll do a 0.2 as well. Make sure that's going the correct direction. Same thing with this one. Grab the sketch entity, do offset entities, going the correct direction. So now we've basically created three very simple sketches here, all reference to the original geometry that was in place. And then I can utilize the existing surface that is in place as well to control the thickness of my new cover I'm putting in. Right? So you can see now I've created that cover and I have all my clearances in place. So once again, the power of this, if I wanted to make a change here, if I clicked on this and I want to change this radius to say maybe 22, do a rebuild, the rest of the geometry for the cover that I put in place now follows along, right? So a lot less manual updating. Everything's already referenced to the original features and geometry. Any changes I make will follow along with that. Same thing if I were to change the size of either of these cylinders, right? If I change the size of the cylinder, the whole will update and follow along. One thing I wanted to note here as well was you can see now when I created this guy, remember we talked about the virtual parts, so I have brackets around part 1 here, indicating that that is a internally controlled or internally saved virtual part in this assembly. If you want this to be an external part, very simply you can right click here and say save part in external file right here. So that's one way to do it. If you want it to be done right off the bat, it is a system option. So if you go up to system options and go to assemblies, there is an option called save new components to external files. So if that is your preference, you can turn that on with the little checkbox, and then when you create a new part or insert a new part into an assembly, it will save that to an external file from the get-go. Right. Another couple things I want to point out here. If you want to see the actual references that you're creating, you can right-click on your component or your feature and hit View External References, and you'll get this dialog box right here called External References. And what this gives you is a couple options here. You can actually see what you're referencing, so the name of your sketch or feature, what the status is, what is being referenced, and then the type of reference that it is. You can also lock all your references from this dialog, or you can break them all. You can filter them by different types, so you can filter them by broken, dangling, in context, locked, or out of context. So quite a few different options that you can look at within here. You can also see things through the dynamic reference visualization. So remember earlier when we talked about parent and child relationships, you can see if I click on this part, it shows me my parent relationships and my child relationships. If I click on the little sphere right here next to it, you can also get a shortcut easy access to your lock and break reference options as well. So that was example 1. Example 2. I have a third example here that I'm just going to show because it's a good real-world example, and it's one that really does require top-down modeling. And I'm kind of going to quickly show you how I did it, and then we'll talk about a few other things. So I'm sure you guys all have one of these in your pockets, right? You have a cell phone, and hopefully or most likely they have some kind of protective case on them, right? So this is a good example because top-down is really needed for this type of modeling because of the complexity of what we're modeling. Say if we want to model an aftermarket case for our cell phone. It's very difficult to model this without top-down modeling because we need to model around the foam to get that form-fitting option. Also, the geometry is quite complex, so if you were to try to do this in a bottom-up strategy, it would be extremely difficult and tedious to figure out all the geometry dimensions and shapes and make sure that it fits very tight and form-fitting, especially since most of these are snapped together, with plastic, right? I have an iPhone modeled here, right? And I've created this case around my iPhone. So we're assuming that this case is a plastic material, snap-on, form-fitting, just like you commonly see with cell phones, right? So what I've done here is if I take a look at this component, you can see that I have a bunch of external references, right? So if I right-click and say external references, you can see all the external references that I've created in this list, which is quite a few here, right? You can see also that I have the external references denoted here in my feature tree based on how I built this part. And I'm not going to go through everything that I'm not going to go through the entire modeling of this just because it takes a little while and you guys probably don't want to watch me model for another half hour. But what I did was I used the original geometry, created a sweep, created a boss, and then created all the cut extrudes with the modeling methodologies that we looked at, either using convert entities or offset entities for some clearance for all of the buttons. So that is your volume button, your speakers, your on-off button, your ringer button, all those types of things, right? So I utilized the existing geometry that was in place and created the holes for those, right? So the methodology here remains the same as the other examples I showed. This one's just a slightly more complex and has a lot more external references to it, to the original phone, right? So a great example of top-down modeling and what you would really need to do here, utilizing the commands we talked about, convert entities, offset entities, to put this in place. So what is the best option out of all these things that we've talked about? Well, there's a few questions that you can ask yourself to kind of clarify what road you're going to go down here, right? First, is the part I'm designing in context going to be used in other models? Well, if so, top-down is probably not the best method due to potential part changes. And this can really cause issues, right? If you have multiple people in your assemblies making changes, what you don't want to do is have a model that has external references placed in multiple other assemblies, because if someone doesn't know that, they come in and make a change, what it's going to do is affect all of the other assemblies where now that part isn't going to fit, right? So you're going to have a problem fitting everything into the other assemblies, and you're going to be wondering kind of why that's what's happening down the road, right? Another good thing to note, top-down models do take a little longer to rebuild. So complex geometry is not a great candidate for this method. If it has many external references to solve, maybe slightly slower on the rebuild. Now the phone, of course, isn't, you pretty much have to do it that way. So there's some times that you just can't get away without doing it that way. Should you model all your features in context? Answer to that, probably not. Get the basic shape, get the outline, then build upon it. So you can always open the part separately and add other detailed features like fillets, chamfers, anything else that's on the part that doesn't necessarily need to be related as an in-context relationship. You can totally add that later and not work in the context of the assembly. Much easier to do, right? So if things go wrong, know where the references are and how to find them. We talked about that a little bit with the external references dialog through the reference visualization or through the right click on the feature or the part to find your external references. That will tell you where they are and what it's referencing. So a couple other things to know in the system options. There's a few great system options that really do help out with external referencing that are probably a little bit underutilized. We talked about this one already, the virtual or external part. So that was the checkbox in the assemblies to save components to an external file. If you have that turned on, it'll automatically go to an external file. I personally like that because then it automatically creates that part as its own file right off the bat, and I don't have to worry about doing the extra step of the saving it out after I've created it virtually. There are some transparency controls for the components that you're editing. So if you do want to see things in a transparent mode, so for instance, if I flip back over to this assembly right here, go to System Options, and we look at the display. So right here under display, there is an assembly transparency for in-context editing. So there's three options in here. You can have it be opaque, which is the way that I have it set. You can maintain the assembly transparency, so that is the individual transparency settings for your model, or you can force the assembly to go transparent, and once you select that, there is a little slider control here that allows you to control the degree of transparency that you're putting on your edited component, right? There's also an option to not create external references if you do not want the external references to be created, and that is once again under your system options. Notice there is a option here for external references, so there is quite a few things in here that relate just to external references. This one that I'm talking about right here is this checkbox right here, which is called Do Not Create References External to the Model. So if you have this turned on, you can still model in context, but it will give you a warning saying that it will not create the external reference. So if you don't ever want external references to be created, make sure you have that turned on. And then the final one that a lot of people don't know about is load referenced documents, right? If I jump back to SOLIDWORKS, if I want to have my reference documents loaded, once again under System Options, External References, there is an option here called Load Referenced Documents right here. Right now I have this set to none, but you can turn this on to be prompting you So it'll ask you if you want to load them all the time. Don't load them, and load them if there has only been changes. They also added a feature or a checkbox called load documents in memory recently in the past few years. So if you don't want the documents to actually open in SOLIDWORKS but only be loaded in memory, you can check that. So a few calls to action that I want to give to you guys. If you want to learn more about top-down modeling, where can you find out more info about this topic? SOLIDWORKS tutorials, a great place, right? If you go into the SOLIDWORKS tutorials within SOLIDWORKS, they have an advanced techniques option in there, and they actually have a tutorial called Advanced Design. And within this tutorial, it talks about a few different things, and one of the topics that they cover is top-down modeling and how to relate components to one another. They use a little hinge model example, but it is a great option for the relationships that I kind of talked about, a little more practice if you want to get some hands-on time with top-down modeling, and it goes over how to set that all up and then make changes and see how that actually propagates to your models, right? Another place that you can find out information about this topic and many other SOLIDWORKS topics, if you go to our website, DASIsolutions.com, go to the training menu, and then you can see all the DASI instructor-led training schedules, and you can select the class type that you want to look at or the class location and filter it out that way. Most of the stuff that I talked about today is discussed within the assembly modeling class, so if you are interested in more assembly modeling topics, that is a good class to begin with that talks about a lot of other things, but including the top-down modeling as well, right? So check those out, get some hands-on time, learn more about this, and see how it goes. Let us know if you guys have any questions. With that being said, I'd like to thank you guys for attending my webinar today. If you do have any questions, feel free to email me. If you have any feedback, feel free to email me.